Okay, welcome back to the 5.3 notes. This is part 3. I want to finish up the rest of these with D, E, and F, and then do example 4. So real quick, on part D, it wants us to evaluate this integral from 9 to 1 of f of x dx. And what you notice here is that the bounds of integration have been switched, okay? And what the property, what we know we can do, is we can go back and flip our integral bounds from 1 to 9, but we have to make everything negative, okay, of f of x dx. Okay, so we'll talk about this in class of why this happens, why if you switch the bounds of integration, why this becomes negative. But for right now, I just kind of want to make sure we can go through this so we have the right answer. So what we know is that the area between 1 and 9 under my function f is negative 1, and that's from here. Okay, that this area was negative 6 and this is 5. So if the whole thing was negative 1, okay, then this becomes negative 1 times negative 1, which just gives me a value of 1. Okay. And you'll have a lot of problems that you'll have to do this for and all that, okay? So part E asks us for the integral from 1 to 7. And, you know, one of the reasons why I draw this picture is so that we can evaluate the rest of the integrals. So I know that the integral from 1 to 7, when we drew this, it gives us a value of negative 6. So I'm going to go ahead and put that in there, that this gives me negative 6, okay? And then part F is a little bit confusing. Part F says the integral from 9 to 7, so we've got to go ahead and switch that, of h of x minus f of x, okay? Now, we knew that the area in between 7 and 9 under h of x is an area of 4, and then the area from 7 to 9 under f of x is equal to 5. So what I want to do is kind of manipulate this a little bit. First, we need to change our bounds of integration, okay? We need to put them back to 7 to 9. But in order to do that, we have to make the entire thing negative. So negative integral from 7 to 9 of h of x minus f of x dx. Okay, and then I'm going to kind of split this up into two different integrals, but I need to keep that negative out front, so I'm going to do this. I'm going to do negative 1 times, okay, the integral from 7 to 9 of h of x dx minus the integral from 7 to 9 of f of x dx. And so then we know that the integral from 7 to 9 of h of x is 4, and the other one was 5, so I'm going to get this. I'm going to get negative 1 times the quantity 4 minus 5. So then that gives me negative 1 times negative 1, which actually just gives me an area of 1. Okay, so I know it's a little bit confusing to operate with this, guys, but it really requires some practice. Okay, and then the last one is example 4. And this is can be a little bit confusing sometimes, but it says to use geometry to evaluate the following definite integral. First, we want to sketch the graph of the function over the given interval from a to b. So our interval goes from negative 4 to 2, and we are graphing the function 2x plus 4. Okay, so I'm going to graph this line over that interval. Hopefully it fits on the graph. But I know I have a y-intercept of 4, so 1, 2, 3, 4. We have a slope of 2. So up 2 over 1, plot a point. Up 2 over 1, plot a point. Okay, so we're going there. Let's go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, and so what I have here, in between negative 4 and positive 2, are these two triangles, and we're bounded between -4, so here's -4, and then here's 2. Okay, and I want to calculate the area under the curve. Okay, so and I've got two different triangles here. Okay, and the first triangle I'm going to label in red, the second one I'm going to label in blue. And all I want to do now is just use geometry, use coordinate geometry to calculate the area underneath the curve, okay? And because these are triangles, we can calculate the area. So I know that this is a 2 by 4 triangle, and but it's below the x-axis, so it's negative. So the area of my red triangle is, I'm going to do -1/2 times 4 times 2. So that area is going to give me, okay, -1/2 of 4 is 2, so that just gives me an area of -4, okay? And then the area of my blue function, okay, this is a 4 by 8 triangle. So the area here is going to be 1/2 times 4 times 8. Half of 4 is 2, and then times 8 gives me an area of 16. Okay, so the total accumulated area, all right, that we need to do here is that this is -4 plus 16. We've got to add them together. And that's going to go ahead and just give me an area of 12. Okay, so, that's all I've got, all right, for these examples. Please get started on your homework and come to class with a lot of questions if you don't know, and check the web for solutions and or the back of the book. So hope you enjoyed this. We'll see you later. Thanks. Bye.